Okay, for question number 9, we've been tested on how to find the area between two curves. Okay? Question 9 reads, let R be the region bounded by the graphs of y equals x and y equals 2x minus 1 half x squared. Question, what is the area of R? So let's go ahead and write down the formula that's going to guide our problem solving process. So the formula for finding the area between two curves. So this is in a function of x, so it's going in the x direction, right? In the direction of the x-axis. So basically, we have, if we're going in the direction of the x-axis, you're going to have two functions configured something like this. Okay. So in a situation like that, you're going to have a function on the top and a function on the bottom. So the area is going to be the integral from the left or smaller x value to the bigger or the right x value of the function that's on the top minus the function on the bottom. And since we're configured vertically, it's going to be with respect to x. There you have it. Okay. All right. So the first question we want to ask ourselves is, what's the top function and what's the bottom function? The problem tells us that the region is bounded. So you have a quadratic function and a linear function. In order for them to bound the region, what must be the case? It must be the case that, let's make a sketch so you see exactly what's happening. It's implied that one function has to be on the top. You can do the calculations if you want. Okay, so we have a quadratic function and a linear function. In order for them to bound a region, we need to have a function like this, the quadratic, and then we have a linear function. The linear function has to be underneath so that it can bound the region, or else it's not going to work. Okay, so it's implied here that the quadratic function is f top, is on top, and the linear function is on the bottom, f bottom. Okay, all right, so let's go ahead and write that down. So the top function f top is the quadratic that's upside down, and the bottom function is the linear function, which is y equals x. There's another way that you can verify this. I'll show you in a second. So in order for us to be sure that the quadratic is on top, we want to look at what is the magnitude, what is the value of each function within the interval right here that they bound the region. So in order to do that, we need to figure out our x left and our x right. These are points of intersection. So to find our points of intersection, we are going to set both of them equal to each other. Okay, so our task that we want to execute now is we want to find x left and x right using algebraic processes. So we're going to set these two functions equal to each other. So x equals 2x minus 1 half x squared. And then we're going to flex our algebra muscles in determining what the value of x is. Okay. All right, let's do it. So we just set it equal to 0. So it's a quadratic. So we have, let's add 1 half x squared to both sides. So we have 1 half x squared, and then subtract 2x from both sides. You have minus x. 1 half x squared minus x equals 0. So how do you solve this equation? How do you solve it for x? Well, we just simply factor, right? That's how you solve quadratic equations. So to factor this, you just pull out x. So we have x times 1 half x minus 1 equals 0. Using the zero product property, we have x equals 0, or 1 half x minus 1 equals 0. Add 1 to both sides, 1 half x equals 1. Multiply both sides by 2, and you have x equals 2. Okay, so in this situation right here, we have the upper bound is 2, and the lower bound is 0. Alrighty, so let's put it all together. I'm going to rewrite everything that we had before so that nobody gets confused as to what just happened. So we said that f top is 2x minus 1/2 x squared. And then f bottom is x. So I also mentioned that there's a way you can verify that the quadratic is on top. So our boundaries are 0 and 2, right? So let's put it down. X left is 0 and x right is 2. Pick a number between them. So let's pick 1, for example. Okay. If you put 1 into the linear function, you get 1. If you put 1 into the quadratic, you get 2 times 1, which is 2, minus 1/2 times 1 squared, which is 1/2. 2 minus 1/2 is 3 over 2. 3 over 2 is bigger than 1, so you see that the quadratic is on top. Okay? All right, so our area, we're now ready to put everything into the formula. It's going to be the integral from x left to x right of f top, oh snap, f top. So this is the biggest mistake most students make, is they switch these two functions around. So you have to make sure that you have the formula written down and you know exactly what f top is and what f bottom is also. Okay, let's go ahead and integrate that and apply f to c1 in finding out what the antiderivative is. So we have the integral from 0 to 2, combine these two together, of x minus 1/2 x squared dx. When you integrate, you have the integral of x is x squared over 2 minus the antiderivative of 1/2 x squared is x to the third over 3, but there was a 2 there, so that becomes 6, evaluated from 0 to 2. Okay? When you plug in the upper limit, you get 2 squared over 2 minus 2 to the third over 6. And then when you plug in the lower limit, you get 0. How convenient. So this becomes 4 over 2, which is just 2, minus 8 over 6. So 8 over 6. Let's simplify that. When we find the LCD, multiply this by 6 top and bottom. So that becomes 12 over 6 minus 8 over 6. And then we get 4 over 6, which reduces to 2/3. Ladies and gentlemen, the answer to question number, what number are we on? Question number 9 is option letter A. Okay, so that's how you find the area between two curves. Support our channel, to give us a thumbs up or a like. Your positive feedback is very valuable to us. Do not forget to subscribe to our channel if you haven't already done so. If you have any questions or comments as indicated earlier, just put it in the comment section below and we'll be more than glad to support you. Tons of support resources can be found at mathgotserved.com, all free. Or just take a look on the link in the description below. Thanks again for watching and have a wonderful day. Goodbye.